In previous videos, we've learned how to write the electronic configurations for atoms of elements. We've learned a couple of exceptions to the rules, a couple of strange ones. We've learned how to write electronic configurations for ions. In this video, we're going to learn how sometimes we can see a shortened version of an electronic configuration. So let's just read here where it says in question 292, it says electronic configurations are sometimes abbreviated. So this word here just means made shorter, or shorthand. Shorthand. So quicker way of writing it than all in one S's, two S's, three S's, and so on. By labeling the inner core of filled inner shells as the electronic configuration of the appropriate noble gas. So what does this mean? Up to the periodic table, and these elements here in group 8, or what's labeled group 0 here on this periodic table, this is group 8, and the nickname here is called the noble gases. Okay, so sometimes you will see it written down, you'll see scientists writing electronic configurations by using these to help us abbreviate. Now, I think the best way to help explain this is to show you a couple of examples of this. Let's say we want to do the electronic configuration of sodium. Say we've got sodium. Sodium has 11 electrons. Okay, so normally we would do this. Na is the symbol for sodium. And we would say 1s2, 2s2, 2p6, that's 10 electrons, and then there's one more, 3s1, like this. Okay, that's the way we'd normally do it. That takes a little bit of time to write all the 1s's, 2s's, 2p's, and so on. So what we can do is we can look at what's the noble gas that came before sodium in the periodic table. Let's go up here. Periodic table again. Here is sodium, 11 electrons. And the noble gas that comes before it, well, it obviously has to be in the higher energy level. It's this one. It's neon with 10 electrons. That's the noble gas that came before it. Now, what this means is that if we look at this electronic configuration of sodium again, from here to here, well, that's just a configuration of neon. 1s2, 2s2, 2p6. That's the electronic configuration for neon. So instead of writing out that section there, what we can do is we can shorten this down by saying neon is the same as neon up as far as here. And then after that, all that's left is 3s1. So we could write the electronic configuration of sodium like that. Sodium is neon, it's a neon core, and then 3s1. Okay? Now, notice you can only do this with noble gases. I can't pick just off my own back, decide, okay, I'm going to do this with fluorine, because that's not a noble gas. I can't say like this, that sodium is like fluorine, then 2p1, 3s2. I can't do that. That's wrong. Okay. You can only use the noble gases. So this one is right. Anything else is wrong. Okay. Let's look at another one. Let's look at calcium. Ca. Calcium has, let me go up here at the table. I think it's 24 electrons, but it could be wrong. No, it's 20, just as well I checked. Here is calcium. Calcium has 20 electrons. So back down, and where is my calcium? There we go. Okay. Calcium has 20 electrons. Let's write it out full the way we normally would. Calcium has 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Just count them up again. 2, 4, 10, 12, 18, 20. Yeah, that's right. So, okay. But again, all of this is a very long-handed way of doing it. I could not write all of that out, and I could go, okay, well, where is calcium in my table? Calcium is here. I've highlighted it in green. What's the noble gas that came before that? So in orange, the noble gas in the period before that is argon. So I know it's the same as argon up to there. And then what is this? This here is 4s and it's 4s2. So the abbreviated noble gas electronic configuration of this is, well, from here to here is the same as the noble gas argon, square brackets, and then there's 4s2 left after that. Okay, so hopefully after seeing those couple of examples, you understand how that works. The first thing I want you to do here is I want you to figure out what are these three elements. Now, sorry, there was a mistake in this last one, so I've had to scribble it out and write it down by hand. But what I want you to do is pause the video and figure out what atoms these are, what elements. So do that now. Okay, so hopefully you have said that this one here is chlorine. Okay, so, and if you didn't, pause the video, go back and see what I'm on about. Argon 4s1 is potassium. And argon 4s2 3d2, I think is scandium, but I'm going to go check my periodic table. Where is it? Sorry, no, there it is. No, I was wrong. It's titanium. So 4s2 goes to there, and then 2 more, 3d2 is titanium. So just as well I checked. Again, you see, that's why it's always worth checking your periodic table. Don't try and remember anything by memory from the periodic table. So the answer here was titanium. So if you got those three right, well done. Now you're ready to move on to the next one. Write out the electronic configurations of the following atoms using the noble gas abbreviation method shown in the examples that we've looked at. So we're looking at 293. I want this one, this one, this one, and this one done. And I want you to tell me about that there. Okay, so let's pause the video and do them now. All right, so the answer you should have is, well, scandium, the noble gas before that is argon. So you should have argon in square brackets. And you should have 4s2, 3d1. Okay, so well done if you got that right. Sulfur then, square brackets, neon. Okay, and it's 3s2, 3p4. Next one is iodine, and the noble gas is krypton, CKR, and then it's 5s2, 4d10, and then 5p5. Now that was a really challenging one, and that's harder than anything you're going to get on the leaving cert. So again, if you got the other three right and not that one, don't worry too much about it. Silicon, neon is the noble gas before it, and then it's 3s2, 3p2. All right, so well done. If you got them all right, then you are killing this. Okay, next one. Why do different isotopes of the same elements have the same electronic structure? Okay, so there are different isotopes. Isotopes have nothing to do with electrons. If you remember, an isotope was two isotopes were atoms of the same element with different numbers of neutrons. So neutrons don't affect the electronic structure. So why do different isotopes have the same electronic structure? Well, they've got the same number of electrons. That's the key thing. Same number of electrons. All right, guys, so that's it. That is abbreviated electronic configurations, and we'll see you in the next video.